Good morning, good afternoon, and good evening to wherever you are in the world. My name is Keith Harvey, and this is Hacking the User Experience. If you're a developer and really want to understand what user experience is and how to take advantage of it, then this course is for you. It doesn't matter what platform you're on or how many years of experience you have, everyone is welcome. The best news is that you don't have to be a designer or an artist. We're going to take a more focused, tactical approach to UX. This is UX for developers. We're going to have a lot of fun, so let's get started. This is not your typical user experience course. Most UX courses focus solely on design, things like information design, interaction design, or visual design. And while design is a very important part of crafting a great user experience, it's not the only part. Looking at it from a developer's perspective, becoming a quote unquote designer isn't always a natural step. Not all of us have the design gene in our DNA. Many of us are more like technical craftspeople that thrive on solving complex technical puzzles and crafting applications with frameworks, tools, and patterns. But if you happen to be blessed with the design gene, that's cool too. So, as developers, we're going to approach the subject of UX from a different angle. We're going to take a more tactical approach by learning how to incrementally improve the user experience by hacking our users' brains. Now, that sounds a bit crazy, but we'll learn together that most of the user experience is driven from deep inside our users' brains. And you can think of it like a root API that we can tap into. We'll learn how to hack this API by making small changes to our applications, and these hacks are designed to lower something called cognitive friction, which we'll learn is the foundational principle to improving the user's experience. And the cool thing is that developers are in the perfect position to do this. Even better is that all of the hacks we'll learn can be used individually, so we can start using them today. We'll also learn that there are great benefits that come from improving the user experience, not just for our users or for the organizations we work for, but for us personally as developers. But ultimately, the main goal of this course is to make us better developers and to make us much more valuable in this new age of UX that we're living in. So here's a quick tour of the journey we'll take together. Currently, we're here at the start in the introduction, but next, we really need to understand what the term user experience means. So we'll cut through the complexity and ambiguity and refactor it down into a simple definition that we can easily remember. So by the time we're through, we'll have a crystal clear understanding of UX and we'll be able to easily talk about it with anyone. Next, we'll prepare ourselves to be UX hackers by learning to adopt a user-centered mindset. We'll also learn to identify and confront the cognitive biases that can knock us off course. You can think of this as preparing to code for a new platform. Next, we'll do a little UX myth busting and debunk some of the common myths that many of us developers have been taught to believe. With this information in hand, we'll be ready to start hacking our users' brains. All of our hacks are designed to incrementally improve the user experience by lowering our users' cognitive friction, which is essentially the CPU cycles in the brain. We'll go over two types of hacks: mind hacks that take advantage of how people think, remember, and process information, and visual hacks that target our users' vision and how the brain processes visual information. Each hack will give us an example of the changes we can make in our applications to activate it. And just like unit tests give us confidence in the quality of our code, we'll learn a couple easy methods to test our UX hacks to ensure they're working. Finally, with our brains full of awesome new knowledge, we'll set a path forward for any of us that want to go deeper into the design aspects of UX. We'll take a high-level look at the language UX professionals use, some of the job disciplines, and set up some more learning resources. In the end, we'll be better and much more valuable developers. This is not your typical user experience course. Most UX courses focus solely on design, things like information design, interaction design, or visual design. And while design is a very important part of crafting a great user experience, it's not the only part. Looking at it from a developer's perspective, becoming a quote unquote designer isn't always a natural step. Not all of us have the design gene in our DNA. Many of us are more like technical craftspeople that thrive on solving complex technical puzzles and crafting applications with frameworks, tools, and patterns. But if you happen to be blessed with the design gene, that's cool too. So, as developers, we're going to approach the subject of UX from a different angle. We're going to take a more tactical approach by learning how to incrementally improve the user experience by hacking our users' brains. Now, that sounds a bit crazy, but we'll learn together that most of the user experience is driven from deep inside our users' brains. And you can think of it like a root API that we can tap into. We'll learn how to hack this API by making small changes to our applications, and these hacks are designed to lower something called cognitive friction, which we'll learn is the foundational principle to improving the user's experience. And the cool thing is that developers are in the perfect position to do this. Even better is that all of the hacks we'll learn can be used individually, so we can start using them today. We'll also learn that there are great benefits that come from improving the user experience, not just for our users or for the organizations we work for, but for us personally as developers. But ultimately, the main goal of this course is to make us better developers and to make us much more valuable in this new age of UX that we're living in. So here's a quick tour of the journey we'll take together. Currently, we're here at the start in the introduction, but next, we really need to understand what the term user experience means. So we'll cut through the complexity and ambiguity and refactor it down into a simple definition that we can easily remember. So by the time we're through, we'll have a crystal clear understanding of UX and we'll be able to easily talk about it with anyone. Next, we'll prepare ourselves to be UX hackers by learning to adopt a user-centered mindset. We'll also learn to identify and confront the cognitive biases that can knock us off course. You can think of this as preparing to code for a new platform. Next, we'll do a little UX myth busting and debunk some of the common myths that many of us developers have been taught to believe. With this information in hand, we'll be ready to start hacking our users' brains. All of our hacks are designed to incrementally improve the user experience by lowering our users' cognitive friction, which is essentially the CPU cycles in the brain. We'll go over two types of hacks: mind hacks that take advantage of how people think, remember, and process information, and visual hacks that target our users' vision and how the brain processes visual information. Each hack will give us an example of the changes we can make in our applications to activate it. And just like unit tests give us confidence in the quality of our code, we'll learn a couple easy methods to test our UX hacks to ensure they're working. Finally, with our brains full of awesome new knowledge, we'll set a path forward for any of us that want to go deeper into the design aspects of UX. We'll take a high-level look at the language UX professionals use, some of the job disciplines, and set up some more learning resources. In the end, we'll be better and much more valuable developers. Welcome back. My name is Keith Harvey, and this is Defining User Experience. In order for us to hack the user experience, we need to understand what the term user experience really means. And that's what we're going to do in this module. We're going to unpack user experience and get an understanding from its surface level down to its deeper meaning. And we'll find the attack vector that we'll use for our UX hacks. By the end of this module, not only will we have a crystal clear understanding of what UX is, but we'll come away with a super simple definition that will serve as our foundation of knowledge for the rest of the course. So let's dive in and find out what this UX thing is all about. Okay, to get started, we need to clear up a common misconception that developers have about UX, and that is that UX and UI are the same thing. UX is not equal to UI, but I can understand the confusion. The UI serves as the delivery vehicle for the user experience. And while UI design and cool animations and sexy graphics are a part of UX, they're actually a smaller part than most developers realize. UX is much bigger. How big, you ask? You can think of it like an iceberg floating out in the Arctic Ocean. The UI is just the tip of the iceberg. It's the most visible piece, and it gets all the attention. It shimmers in the sun, and it's what tourists and photographers come to take pictures of. But underneath the surface is a massive structure, and it's the same with UX. Science and research make up a bulk of the structure, and it's a very active and important community. And design and technology make up the rest. We hear a lot about UX design, but not so much about the science, and that's unfortunate because it sits at the core of UX as a field of study. So let's take a brief look at some of the science involved in user experience. And this is by no means an exhaustive list, but it should give you a good idea of how much research goes into UX. Human-computer interaction, or HCI, is a specialized science created to study how people interact with technology. It's a wrapper around several different types of science and a popular option for university students that are pursuing a field in UX. Human factors is another multidiscipline field that studies more of the physical aspects of people and technology. But similar to HCI, there's a lot of psychology involved. And it's an older field of study, but many people with human factors experience have found a natural place in UX. Cognitive science is a multidiscipline field that focuses on intelligence and behavior and serves a critical role in UX. As we proceed through this module, we'll see why. Cognitive science is truly a wrapper around all the sciences listed below, including some that aren't listed here. I want to call attention to psychology because I believe it's the core foundational science that we as developers should be aware of. Psychology is a huge field of study with many specializations. A couple to be aware of are behavioral psychology, which is all about how people behave, understand, and react, and experimental psychology, which is all about creating tests and experiments to understand people. We'll see how important this is as we move throughout the course. When I first heard about anthropology being used in UX, I was thinking, what, are we digging up lost civilizations and looking for ancient artifacts like Indiana Jones? But actually, anthropologists are incredible about understanding and classifying groups of people. And this is very important when you're trying to understand the needs of users. We also have linguistics, which is really all about understanding all forms of communication, whether it's spoken, written, or visual. And this is really important in UX design. And finally, we have neuroscience. I think we can start to agree that UX is all about the human brain. So the more knowledge we have about its physical functions, the better we can approach improving, and in our case, hacking the user experience. The work in this field of study has opened the doors for us in this course. So as we can see, science and research are a big and critical part of the field of user experience. So now let's take a quick look at some of the job roles involved in UX. Recent surveys about the UX profession have shown that there are about a gazillion different job titles out there. And most often, UX professionals will do work that spans many of these different roles. Again, this is by no means an exhaustive list, but it does cover some of the primary and common roles you'll encounter. First, we have UX researchers. These folks are rooted in the science and research parts of UX and work to understand who the users are and what their needs are. UX researchers are also heavily involved in user testing. Experimental psychologists are particularly good in this role because they have the scientific rigor in creating experiments and gathering data, and also understanding the statistics. Information architects are all about designing, structuring, and presenting information to users. It's important to note that I didn't use the word data. Data is just raw material, where information is refined answers to questions and it's actionable. Information architects also get involved in structuring how a user navigates through information and often have crossover with our next job role, which is an interaction designer. Interaction designers are the first role in our design trifecta. They typically design how a user interacts with an application, how a user moves from point A to point B, how they navigate, how the screens react, how they animate and display information. They typically create sketches and wireframes of the UI in such a way that it creates a great user experience. Visual designers extend the UX work of interaction design and give the actual refined look and feel. They create the graphics, the colors, the animations, all those treatments, and they can have a very profound impact on the emotional aspects of the user experience. It's important to note that people in this role are not just artists or graphic designers. They are UX professionals with all the skills of an interaction designer. Technical designer is a role that I created in my day-to-day UX work. A technical designer extends the work of interaction and visual design and works to package or weaponize the UX into a reusable asset so that developers can implement the UX vision in the most accurate and easy way possible. The technical designer also serves as an intermediary, helping developers understand the value of creating a great UX. And finally, the technical designer also works with the UX team, training them on what is and isn't possible from a technical perspective. And this helps keep everyone focused on realistic UX goals that are extremely effective. And finally, we have UX developers. These folks are usually focused on implementing the UX designs created by the UX team, and they're often found creating prototypes for research and testing. Developers that are focused on the client often find this a great fit. So you can see there's a lot of different roles involved in creating a user experience. It's a big job. So let's get back to our UX iceberg. I think it's safe to say that UX is indeed very big, and as developers, I believe it's critical that we remember this. The reason why is that the ocean floor is littered with the shipwrecks of applications that either didn't know about the UX iceberg or only focused at what's sitting above the surface, the UI. Now that we're understanding more about UX, we have a much greater chance at a successful voyage for our applications. And that's good because UX is continually growing. As a matter of fact, UX has grown so much in the past couple years that our iceberg has calved into two separate pieces. Now we not only have UX or user experience, but we also have CX, what's called customer experience. In this course, we're just going to focus on UX, but I think it's important that we understand, at least on the surface level, what UX and CX is and what the difference is between the two. So let's take a look. Looking at things from the surface level, what we can observe, UX or user experience is how a person feels about interacting with a product. UX is product focused. For us, it's about our application or software, but it can be any other type of product like a device, for instance, a phone or a tablet, or it could be something like a blender or a can of soup. Again, it's how a person feels, their emotions and perceptions about using or interacting with a product. Now, CX, or customer experience, is how a person feels about interacting with a brand. So CX is brand focused. And really, it's any interaction between a company or organization and a customer. For instance, the sales process, how a person interacts with advertisements and marketing, or support and billing, emails, phone calls, etc. It's any interaction during the lifetime of an organization and a customer. Now, while CX isn't a focus for us, We need to be aware of it because sometimes there's give and take between UX and CX in balancing the needs of what's good for the user experience and what's good for the customer experience. So to wrap things up, CX is about how a person feels, their emotions and perceptions about interacting with a brand. But for us, we're going to focus on UX, and let's personalize it a little bit. As developers, on the surface, UX is how a person feels about interacting with my application. Pretty simple. We now know that on the surface, UX is about how a person feels about interacting with our application. But what feelings are we trying to achieve? What's our goal? What's our desired result? I call this the Golden Triad. And great user experiences yield these three feelings. Essentially, we want our user to feel happy, satisfied, and productive. And there's specific meaning behind each of these words. So let's take a deeper look. In our desired result, the first thing we want our users to feel is being happy. Now I know that sounds like a cliche, but it's very powerful, and it's the starting point of our Golden Triad. When a user is happy, good news travels fast. They'll be inclined to tell other people about your application, and it doesn't matter if you're an enterprise developer working on internal apps, or you're a global ISV selling software all over the world, good advertising is an awesome thing. And if you're selling your application, this can lead to increased sales, retention and subscriptions, and higher chances of future upgrades. Next, we want our users to feel satisfied. If your user is happy and satisfied, they'll be way less likely to use another competitor's application. Now, if you're an enterprise developer with an internal application, this loyalty means that your user will actually use and support your application versus looking for ways to get around it. Another benefit is that when a user is satisfied, they'll be less likely to file support requests. One of the more public examples of this was with McAfee. After a UX redesign on one of their products, they reduced support calls by 90%. As a developer, I think that is very compelling. And if your users do file requests, they'll most likely be for ideas on how to improve your application versus complaining. I've experienced this in my own work, and I can definitely say that it's really sweet to hear about people's ideas. I'll take that over angry rants any day. The final feeling we want users to feel in our Golden Triad is being productive. If your user is happy, satisfied, and productive, they'll become what I call an MVP, your most valuable proponents. These people will love your application and you, and they will stand up for you and defend you, almost with a religious fervor. If these people are in any position of influence, they can make your business or your career soar. If you think about it, have you ever seen those epic flame wars on the internet over people defending their favorite tools or apps? These folks will go into battle advocating and defending your application as if they were in a war. These people are your MVPs, all because you delivered a great user experience and made them feel the Golden Triad of being happy, satisfied, and productive. And that's the ultimate result we want our hacks to bring about. So far, we've learned that with UX, we're talking about a person and how they feel, their emotions and their perceptions, and we know that these feelings come from the human brain. Although I've had a few users where I question that fact, but it's true, and science tells us that the brain is an incredibly complex thing. So how in the world can we hack that? I wouldn't blame you if you're a little bit skeptical about it. Well, the good news is that the brain has a root API, like a kernel in an operating system, and this part of the brain is common across to everyone, which is awesome news for us as UX hackers. We'll learn more about it as we move forward, but I wanted to let you know in case you had any doubts. Okay, we've learned about what UX is from the surface level, And we've also learned about our desired results and the Golden Triad of feelings that we're trying to evoke. But what is UX at a deeper level? We can observe its results, but what causes a good or bad user experience? As developers, it's time for us to put on our mining helmets and dig a hole into our UX iceberg and find out. Let's jump in. In my work with UX, I've come up with a definition to explain the deeper meaning of user experience, and I want to share that with you. So UX is the measure of friction between a user and their goal. When friction is low, we get a good user experience, and when the friction is high, we get a bad user experience. Pretty simple. So UX is the measure of friction between a user and their goal. It's essentially any task that a user is trying to complete, any goal that they have while using your application, we want to measure the friction. So what is this friction? What is this? So let's take a look and find out. When we're talking about measuring friction, we're really talking about friction that happens in the brain. And there are three types. The first is cognitive friction, which is the most important, and it serves as the foundation. Remember how we talked about the brain's root API? Well, the cognitive is our entry point for UX hacking. What makes cognitive friction so useful for us is that it's common across gender, culture, and environment. So it's the best way for us to be effective in our UX hacking. Next, we have emotional friction, which is all about people's emotions, feelings, and perceptions. Emotional friction is much more difficult to hack because emotions are truly personal and are driven by many different factors. Remember when we talked about the UX iceberg and how applications meet their watery doom because they only focused on UI design? Essentially, they were inadvertently trying to manipulate the emotional side of the user experience, which is a very risky and often failure-prone approach. Finally, we have physical friction, which is all about how people physically interact with our applications. This could be using a keyboard and a mouse, a stylus, touch, or even gestures. Physical friction occurs when you take your user out of their flow of working. For instance, you might have a task in your application where the user is using the keyboard, they're keyboard focused, and then you force them to switch to the mouse, breaking their flow. That introduces physical friction. Another good example is using gestures for an interaction that might require too much precision. This can really cause physical friction to shoot through the roof. In this course, though, we're going to focus entirely on cognitive friction because it's our global attack vector for our UX hacks. But we also get benefits in reducing both emotional and physical friction because they have strong ties to the cognitive. Remember, cognitive is our foundation. So just by focusing on cognitive friction, we can create really good and solid user experiences. So let's dive in and learn a little bit more about what cognitive friction is all about. Cognitive friction is pretty easy to understand, especially for developers like us. Essentially, it's anything that makes our user's brain work needlessly. You can think of it like CPU cycles in the brain. If the CPU is spiking, then cognitive friction is high, and if the CPU cycles are idling, then the cognitive friction is low. And these could be conscious things for our users: thinking, actively remembering, making decisions, trying to figure something out, really anything that makes them break their flow of work and think. But cognitive friction can also be caused by subconscious things, and many people don't know about this. For instance, when a user is presented with a screen in our application, their brain does a ton of visual processing to figure out what they're looking at. And this is all done subconsciously. If there are issues with the UI that force the brain to work harder in this task, then cognitive friction can shoot up without the user even thinking about it. Later in this course, when we get to our UX hacks, we'll target both conscious and subconscious cognitive friction using mind hacks and vision hacks. Okay, I think we need a good example of what cognitive friction is and how it can sink the user experience of an application. Remember our ships sitting in their watery grave? Well, here's an example. We have an enterprise application, a bug tracking system that is over 10 years old. It's a mission-critical app for a large global company, and it's got some problems. It was built on a very old platform, and it suffers from performance problems. The system is just really slow, and it drives users crazy. The developers that support the application get tons of complaints about it from all levels in the company, and not just because it's slow. Over the 10 years, the application has really increased in complexity because new fields and features were added over the years to support all the different products, all the departments, and all the edge cases in the company. For instance, the screen shown here where you file a new bug has grown to over 100 fields, and many of these fields are hidden in these expandable sections. And because the company is continually growing, there are tons of new users that find the application to be extremely difficult to use. One of the main reasons why is that most users only need about 10 of these fields, but they're strewn about, hidden in these expandable sections. And to make things worse, selecting certain options in the form can make other fields required, but because they're hidden away, it can take a user a long time to find them. It's like looking for a needle in a haystack. Add to that the performance issues of the application, and you have a pretty poor user experience. Now that people have been working for the company for a long time, they've memorized where these fields are, and they can navigate fairly well, but the company's trajectory is bringing in more new users than old, and that is driving a large amount of the complaints. So finally, management decided to give the developers priority to address the user experience of the main screen. And here's what they did. We definitely need to give the developers credit. They did research on the web, reading articles on UX, and really tried to improve things in the short amount of time that they had. And here's what they came up with. The first thing that they did was switch to a new platform, and they dramatically increased the performance of the app. And they created a whole new UI design that was more like what they viewed as an enterprise application. They wanted to make it more professional. And they did a good thing. They decided to do some user testing to get some data and feedback about the new design before they rolled it out. And what they found was surprising to say the least. Using a balance of new and experienced users, they found that they could file new bugs on average 40 seconds faster. That was a massive improvement. But when they interviewed the users after the test, the users reported that they felt it took longer and wanted the old system back. What in the... As developers, I'm sure we can all visualize and hear what was said by the team. What happened? Testing data proves that users are more productive, but they're saying the opposite. So what's going on? The answer is cognitive friction. So let's see why. Let's bring up our handy cognitive friction meter so we can get a visualization of what's going on. The first issue that raised the friction level was visual noise. Now this isn't a huge problem, but compared to the old design, there's much more on the screen that the brain has to process. There's a fancy header with the screen title and the logo, and the menu now extends across the whole screen. And there are navigation helpers on the left and headers that also extend across the screen. Now once users get used to this design, their brains will filter a lot of it out, so that's why we're making the level of cognitive friction low. But it's important to note that cognitive friction is additive, so we need to try to keep it low where we can. So let's take a look at what happened next. So you can see the friction level jumped really high, and that's because the developers decided to show all fields by default. The old design kept most of them hidden in expandable sections, but the team felt it was important to make all of them visible so people could find what they were looking for faster. The problem with this approach is that the cognitive friction jump so high is because that people only need about 10 of these fields. So even though they're all visible and easily accessible, their brains have to process all the fields that they don't need, and they have to try to remember where the fields that they do need live. Because of all the fields are displayed, this causes a lot of scrolling. Now it's important to note that scrolling is not necessarily a bad thing, and that's the reasoning the developers use for their new design. The problem in this case, and the reason why the cognitive friction jumped higher, is that the users don't need all of the fields that they're scrolling through. So each time that they scroll, their brains have to process all the information on the screen and try to determine if the field they need is in view or try to remember its placement. So to combat any issues with scrolling, the developers created some navigation helpers that they thought were cool, and they put them on the left-hand side. Users could click on these to instantly scroll the screen to the appropriate section of the form, and they even added a validation control that could help the user instantly navigate to required fields or fields with input errors. Not a bad idea. The problem was that users didn't see it. What? I mean, it's literally sitting right there. But in testing, it was as if it was completely invisible. Not one user ever clicked on the helpers. So later in this course, we'll find out why when we work on our vision hacks. Now, the cognitive friction barely registered here, but I wanted to point this out. The final issue that sank this application ship was that the save button was not immediately visible. In order to see it, you had to scroll to the bottom of the form. This was most likely just a layout oversight by the developers, but it made the cognitive friction level max out. The reason why is that when people didn't see it, some started to get nervous, and they started thinking about it. Some users poked around the UI, looked in the menus looking for the save. Others thought it was an automatic feature like in Google Docs, which led users to fill out some fields and then close the screen, losing all their changes. Between the worry, the doubt, the thinking, the lost data, the cognitive friction hit critical mass. Wow, we have learned a lot in this module, and we've covered a lot of ground. So let's circle back and review what we've learned. First, we learned that UX is a big field of study, and that it's made up of multiple disciplines spanning scientific, design, and technical roles. We also learned that UX, or user experience, is product-focused, and that CX, or customer experience, is brand-focused. We're focusing on UX, and the product in this case is our application. Looking at UX from the surface level, or what we can observe, we learned that UX is how a person feels about interacting with my application. And we learned that our desired result, or the feelings that we want to evoke in our users, are the Golden Triad of being happy, satisfied, and productive. We then went for the deeper meaning and learned our new definition of UX, which is the measure of friction between a user and their goal. And we learned that there are 3 types of friction that all occur in the human brain, and those are cognitive, which is about thinking and remembering anything that makes the brain work needlessly, emotional, all about the feelings and perceptions, and the physical, how people physically interact with our applications. And we learned that cognitive friction is the foundation and serves as our attack vector, or the target of our UX hacks. I think we can all be proud of ourselves because we have a really good understanding of what UX is, and we can now proceed to prepare ourselves for becoming UX hackers. Welcome back. My name is Keith Harvey, and this is Preparing to be UX Hackers. Now that we've built our foundation of understanding what UX is, it's time for our toughest task, looking at ourselves in a psychological mirror so that we can become as effective as possible in our UX hacking. In this module, we're going to look at the common issues that developers face. If any of these issues don't apply to you, then that's a good thing. But if they do, I encourage you to confront them. The result is that we all become better UX hackers, but also better developers overall. So let's dive in and get started. In this module, we're going to be hacking our user's vision by taking advantage of how the brain sees, how it deconstructs and understands visual inputs. All of the hacks in this module are designed to be used individually, but we'll get an even better benefit by combining them together. Remember that we're not trying to design the user experience, we're trying to hack it, so incremental improvements are what we're after. But if you're interested in learning more about UX design, I'll have some resources for you in the last module of this course. Alright, remembering our definition of UX, the measure of friction between a user and their goal, our main goal is lowering cognitive friction with each hack that we use. Okay, let's jump into our first hack and learn how the brain deconstructs and understands our UIs. When talking about becoming user-centered, I think a good first step is to look at what UX professionals do. For them, being user-centered is all about research. They spend a tremendous amount of attention on finding out who the end user is, as well as what they need. The key word here is need and not want. Once they understand who the user is and what they need, then they can design a great user experience based on that research. Like we learned about UX as a whole, research is a big job. Remember the UX iceberg? User research and the science involved makes up a big chunk of it. The good news for us in this course is that we're going to be hacking the user experience, not designing it. So we'll take a much simpler approach. As developers, the first step towards becoming user-centered is to follow this directive, and that is putting the user at the center of every decision we make. Putting the user at the center of every decision we make. As we progress through designing and building our applications, we're faced with a ton of decisions. Many of those decisions can have a direct impact on the user, the human being that's using our application. At each one of these decision points, we need to consider our user and how the decision will impact them. This exercise alone can help us break out of the technical tunnel vision I mentioned earlier, and it's an awesome and huge first step. Now here's a tough one, at least it was for me. Like I mentioned earlier, as developers, we're taught to think differently than most people. Because of this, it's really important for us to realize that we are not the user. Really, what this means is that when we're making decisions that can impact our end user, we have to realize our assumptions about what the user needs can be wildly different if we think of ourselves as the user. Remember that as developers, we're taught and conditioned to think differently about things. By default, we're just not good analogs for an end user. This is the most common trap that we can fall into. Really, the only good way to understand who your end user is and what they need is to talk to them. And this is why UX professionals spend so much time and attention on research. If you have a desire to go deeper with UX beyond hacking, then meeting and talking to your users is one of the best investments you can make. But for UX hacking, just knowing that we're not the user is an important piece of knowledge to have. There's another thing that we can do to help us think and act in a more user-centered way, and that is, as we face each decision point in our development process, we can ask ourselves the following question. Does the decision I'm making benefit the user or me? Now that's pretty simple. Just asking this question can help us break out of the behavior of just solving the technical problem at hand without considering the impact on the user. Also, looking at the question above, you can substitute me with anything else. The key here is just to get us to consider the user. Now I'd like to share with you 7 common user-centered pitfalls that developers often fall into that can negatively affect the user's experience with their application. We're not going to cover specific solutions to these pitfalls. Really, the most important thing is that we're just aware of them. So let's take a look at the first one, throwing data on the screen. This pitfall is directly related to developers' tendency to have technical tunnel vision. An example is that a developer gets a requirement that the user needs to see some specific information that's in the database. The developer wants to fulfill the requirement as quickly and easily as possible, so they throw a data grid control on the screen, connect it to a query, and boom, done. The problem is that the developer did what was easy for them and not what was best for the user. Often in cases like this, the user sees data and not information. They have to interpret what came from the database into something that's actionable. Also, the control that the developer used, while it's easy for them, might not be the best choice for the user. It's something for us to keep in mind when we're making decisions. Number 2, exposing tech to the user. As developers, we spend so much time working with technology that it's easy to forget that our users don't understand the terminology and other jargon that is second nature to us. Because of this, it's easy for developers to expose technical terms and other data to their users, which can cause confusion and cognitive friction, diminishing the user experience. As developers, we need to understand the language and terms that our users use on a daily basis and shape the text in our applications to match. Another example is exposing class and object names from our APIs up to our users. Instead, we should always use human-friendly language instead. Number 3, forcing the user to think like a DBA. This pitfall most often affects enterprise developers that create data-heavy applications. The pitfall is that it can be easy to force users to work the way the database works. And similar to the previous pitfall we talked about, users may be forced to think about transactions, commits, and other technical terms. An example of this is the developer creates a data grid that allows the user to edit data across many rows coming from the database. Instead of allowing the user to edit the data in cells, saving their work automatically along the way, the user may have to batch up all of their changes and commit them to the database at the end, fixing validation errors in one large batch, versus allowing them to easily undo and redo changes as they work. Again, this is a case of doing what's easy for us and not what's best for the user. Number 4, messy UI. Now, some of us are better at laying out our UIs than others, and not all of us are blessed with the UI design gene in our DNA. But I often have seen developers use their lack of design skills as an excuse to be lazy. And that's pretty tough, which ends up giving the user a very messy UI to work with. The good news is that later in our hacking modules, we'll learn specific hacks to help with this pitfall. The key, however, is for all of us to not give in to the temptation to leave the user with a messy UI. Messy UI is the quickest way to cognitive friction that kills the user experience. Number 5, being inconsistent. Another pitfall that developers can fall into is being inconsistent across the UI in their applications. Some examples are inconsistent command button placement, for instance, switching up save and cancel between screens. Inconsistent use of command names, for instance, labeling one button save and on another screen calling it submit. Beyond text and placement are just general visual inconsistencies, like having varying margins between controls or having form fields that don't line up together. Being inconsistent in your UI is a very easy way to ratchet up cognitive friction, which we know gives the user a bad experience. Number 6, coding for the quote-unquote expert user. This is a pitfall that I have personally fallen into in the past. As developers, when faced with implementing a solution for a complex piece of functionality, it can be easy to use the expert user excuse. Essentially, instead of working to provide an easy-to-use and intuitive UI, we take the easy route and code for the expert user. this mythical user that has an advanced understanding of technology and likes to do things the hard way. Really, like some of the other pitfalls we've mentioned, this is just a case of us facing our desire to solve problems quickly and easily for us versus what is best for our users. Number 7, coding for edge cases. Now, when we're not trying to solve problems in the quickest and easiest way possible, the pendulum often swings in the other direction and we try to create code that solves every conceivable circumstance. This is another pitfall that I've fallen into in the past. Because we're puzzle solvers, we often try to write code to solve problems and edge cases that just don't exist, at least in the real world. We often say to our colleagues, well, the user may want to do this, or the user might need to do that. Most often, it's just an excuse for us to write some really cool code. By understanding who our user is and what they need, we can reduce the complexity in our code and build the right thing the first time. Otherwise, we deliver overly complex applications to our users, killing the user experience. Okay, we're making good progress. We've looked at becoming more user-centered in our thinking, and now it's time to conquer what is called cognitive bias. The first thing to know is that there are a lot of them. A resource that I like to use is the Royal Society of Account Planning's A Visual Study Guide to Cognitive Biases, which lists in a visual format over 104 different cognitive biases spread out over 4 categories. Kind of like how Apple's marketing, they say there's an app for that. Most likely there's a bias too. Now, the thing to remember is that everyone has cognitive biases. So you're not a defective human being if you have them. It's natural. I have my own, just like everyone else. But biases are important because they shape our thinking and our decision making. So in any type of UX work, including UX hacking, it really depends on us making good decisions. So cognitive biases can really derail our efforts. The good news is that biases can easily be overcome just by taking the simple step of identifying and confronting them. It's amazing how much you can increase the quality of your decisions just by making sure you're not injecting bias into the process. As developers, this simple exercise makes us tremendously more valuable, not only for helping us hack UX, but for making sound technical decisions. So let's take a look at what I call the 7 deadly developer biases. Number 1, bias blind spot. Now, this one is the easiest of all biases to overcome. Bias blind spot is the tendency to not compensate for one's own cognitive biases. So just by us working to identify and confront them, we get to mark this one off our list. The key here is that most people don't know they have cognitive bias, and so they have this blind spot and they don't know that they have a problem. But now we've confronted this one and we're good to go. Number 2, deformation professionnelle. Now, to any of my French-speaking colleagues, I apologize if I mispronounce that. This bias is closely related to the technical tunnel vision I mentioned earlier. It's the tendency to look at things according to the conventions of one's own profession, forgetting any broader point of view. For developers, this bias can really interfere with user-centered thinking, or when we're interacting with non-technical folks. To overcome this bias, we need to extend our thinking beyond the technical and just be open to a broader view. Number 3, the Semmelweis reflex. Now, this bias can really apply to anyone, but I've found it really affects developers, and especially developers that have been in their career for a long time. It's the tendency to reject new evidence that contradicts an established paradigm. When we've been in development for a while, we can form strong opinions based on our experience. And when it comes to application design, UX can often bring us to face new ideas and evidence that contradicts what we think is true. The key to overcoming this bias is again to be open and to realize that good user experience comes from research and data to back it up. As developers, we need to resist our urge to hold on to what we know and to be open to new paths forward. The fact that you're viewing this course tells me that you are indeed open to new ideas, so maybe you can cross this one off the list. Number 4, the bandwagon effect. While the previous bias tends to affect experienced developers, this one tends to affect developers that are earlier in their careers. But it really can affect anyone. It's the tendency to do or believe things because many other people do or believe the same. One of the coolest things about being a developer is community. When it's online or in person through user groups, we have a lot of very cool people who are willing to share their knowledge and their opinions. The downside to this is that it's really easy for developers who are early in their career to adopt these opinions blindly. This is especially true online where a senior developer can influence many people at once. The key to overcoming this bias is not to blindly accept what you hear and see from others as fact. Again, it's an exercise of keeping an open mind and considering the source of the information and generally asking one of the most powerful questions, which is why? When it comes to user experience, there are a lot of new ideas and approaches that can directly contradict what many developers believe. So it's important to not just jump on the bandwagon because you might be rejecting something that is really good. Number 5, confirmation bias. Now this is a common bias that affects pretty much everyone to some degree. It's the tendency to search for or interpret information in a way that confirms one's own preconceptions. Essentially, this bias comes into play when you have a strong opinion about something and you search for and filter information coming to you based on whether it supports what you believe. An example of this would be a developer is tasked with building a new application that has a good user experience. Now the developer thinks that data grids and tree controls are the best controls to use in a UI. So when they go out to search Bing and Google for information on user experience, they're searching for using data grids and trees. So it's taking their belief and finding information that supports it, that gives them a confirmation. Really, the way to overcome this bias is just to freely admit that we have our own opinions and ideas, and that's okay. But it's also important that we make sure that we're open to evaluating different ideas and approaches. Number 6, status quo bias. As developers, we live in a world of change, and many of us have to constantly keep our skills up to date and keep learning so that we can adapt. That's why we use awesome things like Pluralsight. But most people don't like change, and if they can keep things the same, they do. And that's what this bias is all about. It's the tendency for people to like things to stay relatively the same. This bias can really affect enterprise developers that are insulated from rapid technology change, but again, it can affect, pretty much anyone. The problem with this bias is that it can interfere with exploring and accepting new ideas and approaches. And when it comes to UX is really about change and new ideas. So the key to overcoming this bias is to step out of your comfort zone and look to see what's on the outside. Anytime we do that, it can be a bit uncomfortable, but usually the results are worth it. Number 7, reactants. Now this bias is something that I've had to deal with personally, and I think a lot of skilled and talented developers, folks like you and me, we can tend to become very independent in our thinking. I really don't see this bias too often with individual developers, but I do see it quite often with development teams, especially when they first start interacting with UX professionals. It's the urge to do the opposite of what someone wants you to do out of a need to resist a perceived attempt to constrain your freedom of choice. For a development team just starting to work with a UX professional, all of a sudden they're being told how to build their applications. And if the UX professional doesn't build their relationship properly, the development team may suffer from reactance and resist any UX direction and guidance, basically doing their own thing just because they have the perception that they're losing control. The key to overcoming this bias as an individual and as a team is to understand that most UX professionals want to partner with you to build great user experiences. Again, it's about being open-minded. Now it's time to circle back and take a look at what we've learned. As we prepared to become UX hackers, we learned about becoming user-centered in our thinking and that it's about putting the user at the center of every decision we make. We also learned that we are not the user, mainly because we think differently and see the world differently than most people. It's how we were taught. We also learned a simple question that we can ask at each decision point in our work, and that is, does the decision I'm making benefit the user or me, or anything else really? And finally, we took a tour through 7 common pitfalls that can derail us. Then we moved into learning about cognitive biases and found out there are a lot of them. And we also learned that they're common and that everyone has them and that they shape our thinking and our decisions. And because of that, biases can derail our UX hacking efforts. The key is to identify and confront our cognitive biases and keep an open mind. In the end, we'll become much more valuable as developers and will make better decisions and reduce the risk of failure. Now we've covered a lot of ground here, and now it's time for us to do some UX myth busting before we move on to our first UX hacks. Welcome back. My name is Keith Harvey, and this is UX Mythbusters. As developers, there are a lot of things that we're taught to believe that are just simply not true. And when it comes to our goal of improving the user experience, these myths can lead us in the opposite direction. Well, we definitely don't want that. So let's dive in and take a look. I want to make sure to remind all of us that if we've believed in any of these myths that we're going to talk about, that it's not our fault. UX myths are born out of incorrect and outdated information. And just like any other science or field of study, time uncovers new truths and new ways of looking at things. So some of the myths that we're going to look at made very good sense in the early days of computing. If you're a modern web or mobile developer, many of these myths may have already been busted for you. So if that's the case, then you're in great shape to start UX hacking. However, if you're a developer with decades of experience or an enterprise developer, you may be at more risk when it comes to these myths. But the good news is, just like confronting cognitive biases, just the act of learning about these myths will make you a better developer and a better UX hacker. Indeed, knowledge is power. So let's take a look and bust 10 common UX myths that can lead us off course. Myth number 1, counting clicks. The user should never have to click more than n number of times to do something. Some say it's 3 clicks, some say it's 2, but most likely you've heard this one before. So why is this a myth? Well, it's important to note that users, human beings, are not robots. We don't have pre-programmed click counters in our head that trigger a bad user experience flag in our API of a brain. Tons of user tests and research has shown us that users will click as long as the cognitive friction is low and as long as they are getting closer to their goal. Remembering our definition of UX, which is the measure of friction between a user and their goal, this makes sense. So these tests show us that it's not the number of clicks that matter, it's the amount of friction in the process. However, the number of clicks can matter if it's a highly repetitive task. But again, we might want to ask, why does the user have to do that so much? Maybe it's something that could be automated. Myth number 2. White space. White space is wasted space, they say. We need to show the user as much data as possible. Well, I think we've all heard this one before. UIs like this can be scary to a lot of developers, but in a lot of cases, this is exactly what the user needs. Clear, actionable information, but instead they get something like this. Pretty crowded. So why is this a myth? Well, the fear of white space really comes from the early days of computing, where we had small, low-resolution displays and text-based UIs. Screen real estate was definitely at a premium. But the world has moved on, and now we have high-resolution displays, incredible text and graphics rendering, so that's not really an issue anymore. Another reason why developers eliminate white space with a vengeance is to support the mythical power user. These incredible superhumans need to see as much data on the screen as possible. Well, at least that's what some developers think. Unfortunately, people's brains just don't work that way. But most of the time, crowded UI comes from just not knowing what the user's goals are. So developers throw whatever data they have available on the screen. White space, however, can help lower cognitive friction by allowing the brain to deconstruct and process the UI more easily. And white space also helps the user focus on their goal more quickly. And again, it can smooth out the friction between the user and their goal, which is exactly what we want. One of the ways it does that is by promoting visual grouping between elements and blocks of information. In the next module, we'll see hacks for that. And finally, a clean open UI can lower emotional friction, making people feel more relaxed when using an application. So bust this myth and embrace the white space. Myth number 3. Scrolling is evil. Everything should fit on one screen. Users hate to scroll, they say. So why is this a myth? Well, user testing has shown that vertical scrolling is just not a big deal. And as a matter of fact, it's become a habit for most users. Many users scroll without even thinking about it. And even users that say they hate to scroll will actually do it without issue. This is a good example of knowing what your users do versus what they say. However, unless you're on a tablet or another touch device, be really careful to minimize horizontal scrolling. This can raise cognitive and emotional friction very quickly, especially with mouse users. Myth number 4. Small details don't matter. It's good enough, they say. Let's just ship it. Or is it? So why is this a myth? Well, small details can dramatically improve the user experience. And we'll see this in practice once we start our UX hacks in the next module. But small visual changes can help reduce cognitive friction, which helps improve the user experience and can also help the user focus on their goal. As developers, we're taught to solve technical puzzles and implement functionality, and this can often take precedence over the details in our UI. It's important to remember that the UI is our delivery mechanism for the user experience, so small details matter quite a bit. Details are really important if you're selling something. A great example of this is the story of the $300 million button. BestBuy.com had a login form with a register button when a user clicked the checkout button on their site. This put an obstacle in between the user and their goal, which was to buy something. This led to a lot of users abandoning their carts and leaving the site. So after working closely with UX professionals, Best Buy removed the register button and replaced it with a continue button and some text letting them know the benefits of registering. The number of abandoned carts dropped, and calculations showed that this one small detail, a continue button, saved Best Buy $300 million in lost sales. This is a great example of how cognitive friction can kill the user experience and kill sales too. Finally, the perception of quality is skin deep to the brain. When a user looks at your app for the first time, the brain makes an almost instantaneous decision about the quality and worth of your app based on the visual details alone. If the UI is messy or there are layout inconsistencies or other small issues, people will view your app as low quality. So small details do matter to the brain, which we've learned is where the user experience comes from. Myth number 5, more choices. The user may want to do this. The user also may want to do that, and power users want everything. So why is this a myth? Well, choices can actually present roadblocks to users. In our definition of UX, we say it's a measure of friction between a user and their goal. And a way to visualize this is to think of the user in a tunnel. They're on one end and their goal is on the other. Choices can turn this straight path into a series of forks and crossroads. And this makes the user stop and think, which raises cognitive friction. Even the mythical power user just wants to get straight to their goal. Having multiple ways of doing something can slow users down and also make the UI harder to learn. And this can be a real killer if you're an independent developer or work on a small team with limited support resources. And like we learned about scrolling, users will often say yes to more choices in a UI, but in many cases it negatively affects the user experience. Research has shown that users have a bad track record at predicting the value of a feature or a choice in the future. As developers, we need to stop offering more choices and features, and we should really look for one good way of doing something. Finding that single path between the user and their goal can be hard work, but it's a critical step in order to build a great user experience. Myth number 6. Users make good choices. The user knows what they need, they'll select the right option. Or will they? Building off our previous myth about more choices, we'll find that our users need our help. When users are presented with making a choice in a UI, most of the time the decision will be made subconsciously by the brain, without a lot of thinking involved. But if there are multiple choices involved, this can paralyze the thought process of what little there is. This often leads to some users just making guesses, which can lead them to making bad choices. As developers, by focusing on the one straight path between a user and their goal, we can lower cognitive friction, the mental CPU cycles that choices represent, and we can influence the user experience in a good way. Myth number 7. Users know what they want. The customer is king. They will drive the features and requirements. So, listening to your users' requests are a good thing. So why is this a myth? Well, it's important to know that what users want doesn't necessarily equal to what they need, and they'll often request and agree to more than their brains can handle. Like we mentioned earlier when talking about choices, people are horrible at estimating the value of features in the future. As developers, the only way we can really be sure about a feature is to test it live with real users. So while customers are indeed kings, we need to treat them as if they were our children and protect them from harm. As developers, another pitfall we need to avoid is requests made in group settings. Often people in groups will agree to things that they would never agree to in a one-on-one discussion. This is usually due to one or a few individuals influencing the group. So this is something important to keep in mind. Our true task is really to find out the user's goal, that one straight path between the user and their goal, to determine the true need. Myth number 8. Usability is greater than beauty. Users just care if it's usable. They don't care what it looks like. Or do they? Users will almost instantaneously judge your app's quality and credibility just by its appearance alone. And if you're a web or mobile developer, this could be a really bad thing because people will just abandon your app without discovering any of the good stuff you've created. Even if you're an enterprise developer with a captive audience, users will make the same judgment. Good visual design, how the UI looks, can lower emotional friction, giving the user experience a boost. And while this course isn't focusing on design, it's something that we should all invest in at some point. Even if you're graphically challenged, There are a lot of resources and people out there that can make your app look beautiful, giving your awesome app the credibility and quality perception it deserves. This is a case where perception is reality. Myth number 9. Let's do it like Apple, or Microsoft, or Google, or Amazon, etc. They spend billions on research and development. Well, that does make a lot of sense, so why is this a myth? Well, Amazon.com's menu system may not be appropriate for your time card application. When looking at what these tech giants have done with their UI, you have to be careful that it supports a good user experience for your users' goals. The key is to not blindly follow someone else, but to make sure that it makes sense. But if you're integrating into their platform, it makes sense to match their UI conventions. So a good example of this would be Office or browser add-ins, that type of thing. And it really makes sense to use the UX and UI conventions of Apple and Google and Microsoft for mobile applications. I always highly recommend reading and following their guidelines. In many cases, your app can be rejected if you don't. And finally, myth number 10. UX is a project step. The code is done. Let's quote unquote UX the UI and ship it. So why is this a myth? Well, improving the user's experience is a continual and iterative process, and it's something that you can continually work on and refine throughout the whole life cycle of an application. And the earlier you start in the development process, the better results you'll get overall. It will also be much cheaper too. I think the easiest way to think about this is to remember the UX iceberg. You definitely don't want to be one of the hulking wrecks at the bottom of the sea. The important thing to remember is that no matter what stage your application is in its life cycle, you can incrementally improve the user experience. In our next module, we're going to start hacking the UX and do just that. As we look into our psychological mirror, there are two areas that we're going to address in this module. The first is to become user-centered in our thinking. Essentially, we want to put our end user in the center of every decision we make. The second is to identify and confront the cognitive biases that can lead us into making bad decisions. Really, what we're talking about is changing our behavior, which I can definitely say is pretty challenging, and I think it's one of the most difficult things for developers to do. Another way of thinking about this is preparing to code for a new platform. If you've ever had to switch to a new platform or language, you have to understand the API and the benefits and pitfalls of the platform. In our case, that platform is the human brain and the root API that we've mentioned previously. But overall, the goal of this module is to help equip us to make better decisions about what parts of the user experience to hack. We also get another cool benefit, and is that we'll be able to learn to make better decisions in our day-to-day development work, making us much more valuable. We'll also get the benefit of being able to avoid the common traps that can keep us from being effective UX hackers. Really, this is the most difficult part of our course because we're facing ourselves and we're attempting to alter behaviors that have been ingrained in us for a very long time. But the cool thing to know is that you can do it. I did, and I know you can too. Being developers, we have some challenges to face that can keep us from being user-centered and can also introduce the biases that affect our decision-making. The first is that we're problem solvers by nature, and we solve technical puzzles for a living. Because of this, we just see the world differently than most people, which in itself isn't a bad thing. We just have a different perspective. But this can lead us into thinking with a technical tunnel vision, where we see only the tech and ignore the human part of the equation. That is, the human beings that are using our applications. It's not that we're doing anything wrong, it's just how we're taught to think from the very beginning of our careers. It's this teaching and conditioning that creates our behaviors. It's hard-coded into us. But some of these behaviors we need to change, and that's the most challenging part. I think it's fair to say that changing behavior can be hard. But the key thing to remember is that it can be done, and I can personally attest to that. It just takes time, and the amount of time really depends on you, because it's a personal thing. Some folks are able to change behavior very quickly, and for others, it may take a while. But the process isn't complicated at all. You just need to substitute an old behavior with a new one, and repeat that a lot. The more repetition, the quicker you can make the new behavior your default. Really, the one piece of advice I can give you is just to stick to it. You can definitely do it. All right, let's move forward and learn what being user-centered is all about. Now, the human brain is a very complex thing, so we need an ultra-advanced tool to help us understand what's going on inside. I'd like to introduce you to the Pluralsight Brainovision 2000. This was given to me by a mysterious Pluralsight author from the future, one that looks nothing like a silhouette of my author pick. And he assured me that this was the most advanced 8-bit technology in the world, and that it looks nothing like PowerPoint animation. Rest assured, the PSB 2000 will serve us well, so now let's finally get to our first hack. Our first hack is the shapes hack. Let's make our UIs easier for the brain to deconstruct by using shapes. Okay, we've got Brainovision 2000 loaded up. Let's learn how our user's brain understands what it sees by using this picture of a house. Your user's brain is really efficient at deconstructing an incoming visual input, essentially a picture. It's important to remember that our users see in 2 dimensions. Their brain does fancy processing that gives them the perception of 3D, but the brain does its main processing in 2D. One of the first things that it does is try to break it down into a series of shapes. Let's take a look at that. And based on the shapes that it identifies and how they're structured, it can then match it to data encoded in memory. In this case, a house. It will then use similar shapes processing to figure out the finer details as the user's eyes scan over the image. This happens in milliseconds, and your user's brain is really good at this. So what does this shapes processing have to do with our UIs? Well, regardless of the application, the OS, or the device, your user will have some stored UI patterns in their brain. These patterns are broken down into geometric shapes that their brain uses to help identify what they're looking at. If your UI can be easily deconstructed into these shapes, the brain will be able to match it against stored patterns, thus understanding it with less cognitive friction. So let's look at a UI that is challenging for the brain to deconstruct into shapes. Now, I have a feeling that your cognitive friction just spiked. I know mine did. Using our simulation, there are a few shapes that our user's brain might see. We have a window title and header area. We have the tree and the data grid. And we have this mess in the middle. There's also an ad and finally the status bar at the bottom. The problem is this area here. It's so densely packed that the brain has a problem figuring out the basic shapes it needs to understand what it's looking at. If this were a video game, the user experience would be wasted. To understand why the cognitive friction is so high with this UI, and why the brain has such a problem deconstructing it into shapes, we need to know a little bit more about how our user's vision works. First, there's central vision, and this is where your user sees details, and it's small, about the size of a US quarter or a euro coin. We also have peripheral vision, and this is where your user's brain does its shapes processing. Peripheral vision can't discern details like central vision, but your user's brain uses it a lot to figure out the meaning of what it's looking at. The only way for a user to understand detail is to scan their eyes over the UI, And needless to say, central vision is a high brain CPU resource and can really raise cognitive friction. In this case, the middle area of the UI can't easily be deconstructed with peripheral vision, so the user will have to use central vision to try to figure out what they're looking at. So let's take a look at a modified version of the UI using the Shapes hack. You're looking at a wireframe diagram, which is essentially a sketch, and we'll be using these throughout this module. Now I bet your cognitive friction just dropped a whole lot. Mine definitely did. And the reason why is that this UI is extremely easy for the brain to deconstruct into shapes, especially our troubled middle area. So let's take a look at the shapes processing now. We have the title and menu bar like before, the tree, and the grid. And now in the middle section we have all of the transforms as well as the transform details. I removed the add in our example, and finally we have our footer. Now when our user looks at this UI, they can quickly figure out what it has to offer and can understand it much more quickly without using central vision. So let's review the shapes hack. Our users' brains love easy to see shapes. This processing happens each time the user looks at our UIs and uses highly efficient peripheral vision. We learned that central vision is a high brain CPU resource, and we also learned that peripheral vision is a low brain CPU resource. If the user has to visually scan our UIs to understand them, then the cognitive friction will be high. But if the user can break our UIs down into big shapes, the cognitive friction will be low. Okay, that's the shapes hack. Next, we have the white space hack. Let's lower cognitive friction by allowing our users' brains to rest by using white space. We covered white space in our UX myth busting, so let's see how we can take advantage of it. Using the UI from our last hack, let's take a look at a good example of white space issues. In our previous hack, we talked about how forcing the user to use central vision can really raise cognitive friction, and it gets worse. If there isn't enough white space available in the UI, then the brain has to constantly be processing visual information with central vision and never gets a chance to rest. Looking at this UI, we can only see a few places where the brain can rest. We have a spot up here on the menu bar, we have a small patch down here by the add, and a little bit here in the middle. And these are the only oases in this vast desert of visual clutter. Okay, here is our wireframe from the Shapes hack. With the middle section being overhauled, we have a lot more white space available. So now our user's brain can relax. For example, we have plenty of white space around where the user will be focusing, inputting data. And we've also put some white space between the labels and controls to help give them visual separation and grouping. If you have a crowded UI, try applying this hack and improve the user experience by giving your user's brain a more relaxing way of looking at your UI. So let's review the white space hack. A crowded UI requires your user's brain to use central vision, which makes cognitive friction high. Remember that central vision is a high brain CPU resource. But using white space allows your user's brain to use peripheral vision, which helps make cognitive friction low. Peripheral vision is what the brain uses to understand what it's looking at, to get its meaning, and it's much more efficient and faster than central vision. And it allows the brain to rest while visually processing your UI. Another benefit is that it helps users focus on important information that you need them to use central vision for by giving them a buffer. Okay, that's the white space hack. Next, we have the grouping hack. Let's make our UIs easier to understand by grouping elements more effectively. It's important to note that your user's brain loves groups. Actually, it loves anything structured, hierarchies, numbered lists, groups, etc. So let's take a look at how we can improve the user experience in our UIs by hacking this part of our user's brain. Okay, let's look at our UI example again to see grouping issues. Actually, this UI is using a lot of grouping, but in a self-defeating way. Here you can see that the groups are tightly packed together and are almost touching, and the content inside the groups are so tightly packed that it can be more difficult for the brain to see them as individual groups. You can see how our previous white space hack could really help here. Another issue is that we actually have UI elements from one group touching or overlapping another group like this checkbox and button. A user looking at this middle section using peripheral vision will have a very tough time discerning the individual groups. They're forced to use central vision and a ton of visual scanning with their eyes. Again, cognitive friction skyrockets. So let's take a look at how we can fix the grouping issue that we just looked at. One of the good grouping techniques that the original UI was using was group boxes. Here we can see those much more clearly. We have a regular expressions group and a replace group. Using the white space hack, we made the groups appear to be more distinct by giving some separation between the border of the group and their content. We also put a little more white space between the groups so that our user's brain can easily pick them out using peripheral vision. And finally, we moved the toggle button and reset button from the border of the group into the content area of the control. Remember, in the UI we just looked at, they were touching and overlapping with other groups, making them less distinct. Now our user's brain can see a very clear border around each individual group. And the key to effective grouping is to make sure your groups are visually distinct using peripheral vision versus central vision. Also, you can start to see the power of stacking or combining individual vision hacks together. Here we use the white space hack quite effectively to make our grouping hack work. Now, group boxes are great for desktop applications, but there are many other ways of grouping. Let's take a look at a few others. Here's an example from Windows 8. Microsoft has done a great job with grouping in their modern UI by using simple rectangles with consistent white space between them. I guess in this case it's purple space. And even small groups can easily be seen. It's important to note that if you have collections of groups, make sure to use consistent white space between them. This allows your user's brain to see them more easily. And if your user's brain can see them more easily, then that means cognitive friction will be low. Here's a wireframe example of grouping without white space. Here we're using solid colors to show large groups in a UI. This looks a lot like something we do for our shapes hack. Remember, if you think about it, the shapes hack is grouping done at a macro level. So here we use dark gray for our header group, a blue color for our navigation group, and finally we have our content group. So in this case, we created really distinct grouping by just using color alone. And again, we can also see how our vision hacks combine together. Now let's take a look at issues you might run into when dealing with repeating groups. This is a really common issue when your UI is displaying data from a database. Here we have an example that is showing US state flag redesigns consisting of an image, a title, and a description for each record in the database. In this example, cognitive friction is going to start to climb quickly because it's difficult to figure out which image goes with each title and description. Now our wireframe just has placeholders for the images. If this was a real application, Our user could probably figure out which image goes with each title and description, but they'd have to think about it. Based on what we've learned about UX, we know this would raise cognitive friction. And it can also raise emotional friction because the user could quickly become frustrated. The reason why this UI has issues is that the groups are not visually distinct, and the white space between each element in the group and between the groups are the same. So let's see how we can fix this. So here's a slightly modified version that has much lower cognitive friction. The user's brain can now quickly identify the groups using peripheral vision. We can see a distinct group here for Alaska and a distinct group here for Arizona. The keys to fixing this was to move grouped items closer together and to use a larger amount of white space between individual groups so that the user's brain can quickly identify them. Here's a small variation to consider. Instead of using white space between groups, you can also use a separator. In this case, I used a horizontal line. This is just as effective as white space for separating groups, but you lose the benefit of giving the user's brain a chance to rest between the groups. So let's review the grouping hack. Your user's brain loves groups. In general, your user's brain loves groups, lists, hierarchies, anything that helps it organize what it sees and thinks about. So grouping things in your UI is a great way to lower cognitive friction. The grouping, white space, and shapes hacks all work together. Combining them is a great way to go. Crowded groups that are too close together requires your user's brain to use central vision, which makes cognitive friction high, something you definitely want to avoid. Repeating groups without enough visual separation makes cognitive friction high. Again, something we want to avoid. And finally, white space within and between groups allows your user's brain to use peripheral vision, which helps make cognitive friction low. All right, that's the grouping hack. Next, we have the alignment hack. Let's eliminate the silent UX killer by aligning elements properly. This is a really important hack, so let's find out why. Let's take a look at our trusty UI and see how alignment issues can negatively affect the user's experience. It's important to note that alignment is one of the most common problem areas for developers. Not because we're lazy or don't care, but mostly because we don't understand the negative impact it has on our users' brains. Even single pixel misalignments can make cognitive, and in some cases emotional friction, shoot to the sky. Now this UI has a lot of alignment issues, so let's zoom into the remove group so that we can focus a little bit better. Now whenever we approach aligning elements in our UIs, it's important to consider the reading direction of our users. If your users read from left to right, then you want to make your primary alignments on the left edges of your UI elements. If your users read from right to left, like in Hebrew or Arabic, then you want to make your primary alignments on the right edges of your UI elements. In this example, we're working from left to right, so let's take a look at some of the alignment issues. First, we have an alignment on the left edge of the checkboxes, and another on the first set of labels. Now this is just a few pixels, so no big deal, right? And that's what I used to think. But when the brain is trying to resolve groups of items and scan information in the user's reading direction, even single pixel misalignments can cause the brain to slow down and use more CPU. Some users' brains are more forgiving than others, but the problem is the same. By aligning things precisely, we can put the brain scanning on rails, making it work much less, which lowers cognitive friction. Moving ahead, we have an alignment on the left edge of the input controls and the second column of checkboxes. We have one on the lead dots label down at the bottom and one on the words label. Another one on the last N label, one on the to label. We have one on some more input controls in the third column of checkboxes. And finally, one on the top right 2 input boxes. Actually, there are a lot more small alignments to consider, but these are the main ones in the user's reading direction. Pretty messy, huh? Just think of what's going on in the user's brain. That's a lot of cognitive friction. But it gets worse. Those were just the horizontal alignments. Let's take a look at the vertical alignments. Here we have an alignment through the top input controls. Notice the vertical alignment of the first N and last N labels. Here's the alignment of the second row of input controls. You can see that the vertical alignment of the from and to labels are different from the first row. The next row is pretty close to the second. This one is yet again different, and this final alignment is different too. It's really important to remember that your user's brain is subconsciously dealing with these alignment issues. It's not something that your user is going to consciously think about unless it's really bad and very noticeable. So again, even small variations in alignment will slow the brain down and increase cognitive friction as it tries to resolve the groupings of UI elements. And that's something we really want to avoid. What makes this particular example worse is that it's happening in a constrained space. Your user's brain resolves alignments within groups. So in this case, their brain has to work really hard using central vision to try to figure everything out. Also remember that we're just looking at one group out of a big cluster. Before we work at fixing the issues we just looked at, let's take a look at some of the alignment options we have available to us, especially for labels and controls. Here is a wireframe where I've taken the labels and controls from our example and just stacked them vertically. Let's set aside the actual meaning of these controls and just look at the alignment alone. In this example, we're using left-aligned labels and controls. We have a consistent horizontal alignment of the labels as well as the controls. Everything is consistent and will work really well for our user's brain. One of the challenges you can run into with left alignment is when you have long labels. This can also happen if your application is localized and translated text is much longer. In this example, you can see the problem. As the overall label width increases, small labels start to lose their visual connection with their controls. This is something you want to keep in mind when using left alignment. Next, we have right-aligned labels. Right alignment works really well, and it can overcome some of the label length issues we saw with left alignment, since there's always a consistent distance between the labels and their controls. Another benefit is that we get a nice visual tunnel that the user's brain can easily scan. This makes it really easy for the user to understand what they're looking at with low cognitive friction. Finally, we have top-aligned labels. This alignment option overcomes the label length issues and creates a nice single clean alignment. It uses more vertical real estate, but it's also a really nice low cognitive friction option. Okay, let's talk about how grouping affects how the brain processes alignments. When your user's brain is processing your UI, it will consider alignments within those groups. Groups create an alignment scope. In this case, the main alignment scope is our group box. But within the group, there may be subgroups or conceptual groups to consider. For instance, the first N and last N might be considered a group, as well as the from and the to. The characters and words look like they conceptually go together, And crop has an associated text box that makes up a subgroup. The checkboxes go together as a group. And finally, we have the lead dots label and control. So let's take a look at what we've learned about alignments and apply the alignment hack to this example. Here's the wireframe that I created. The cognitive friction will be much lower when our user's brain tries to process it. We have clean, consistent alignment across the subgroups. And by using the white space and grouping hacks, the user's brain can resolve the alignments separately across the groups. The user's brain will say thank you when it looks at this, and that's definitely a good thing. We've spent a lot of time talking about the alignment of labels and controls, including groups, but there's one more common issue that I see quite a bit in my work, and that is alignment within containers, things like buttons. Here's a wireframe of a real example I came across recently. The developer created a custom button that displays text, in this case more information. If we look at the vertical and the horizontal alignment, it's pretty clear that the text is not aligned very well. Remember that alignment is the silent UX killer, and this button is definitely doing some damage. So let's update our wireframe with what I call the center-center alignment hack. Whenever you have elements like this, it's pretty safe to vertically and horizontally align the content to the center. Now this custom button won't kill our user's experience. Okay, let's review the alignment hack. Alignment issues are truly the silent UX killer, and we learned that the alignment issues are registered subconsciously by the brain unless they are really noticeable. We also learned that misalignments can make cognitive friction high by slowing down the brain's ability to process visual inputs as it transfers from using peripheral vision to central vision. And we learned that even single pixel misalignments can cause cognitive friction. However, the tolerance level depends on the user. In looking at alignment options, we saw there are many options available to us, but whatever we choose, the key is to be consistent. And we should base our alignments with the reading direction of our users. We also learned that white space and grouping help create alignment scopes that we can use when aligning subgroups of items. And we also learned about using the center-center alignment trick for containers like buttons. And most of all, we learned that good alignment helps our users' brains see our UI more easily. Okay, that's the alignment hack. Next, we have the attention hack. Let's make our UIs attract our users' attention or allow them to focus more effectively. Did something grab your attention just then? If so, your peripheral vision is working pretty well. In this hack, we're going to see how peripheral vision can be really powerful at attracting or distracting our users' attention. We've got Brainovision loaded up. Let's see an example of something called change blindness. This is a common issue in applications where a user doesn't notice that something in the UI has changed, and that something might be important. In this example, our user is searching for the word northern in the files above and wants to replace it with the letter N. And when they click the apply button, it will affect these two file names. But what's important to remember is when they go to click the button, their central vision will be fixed, and the changed data will be sitting in their peripheral vision. Since the change happened so quickly, the user, including myself, didn't see it change. Change blindness issues can raise cognitive friction because the user will often be confused for a short period as they try to figure out if anything happened. Eventually, they'll scan the files above and see the change, but they have to use the expensive central vision and associated thinking in order to do it. So let's see the same example, but we'll take advantage of the user's peripheral vision to alert them of the change. This time, when the user clicks the apply button, we're going to do a couple tricks to the cells above. First, we'll change the data to a bold font, and then we'll have an animated border appear to catch the user's attention to each cell that's changing. The reason why this works is that your user's peripheral vision is very efficient at detecting movement. It's built into their DNA, and it's a reason why their ancestors survived in the wilderness. Being able to detect a predator sneaking up on you is a powerful ability. It's the same ability that allows us to get the user's attention. Now let's see how movement in your user's peripheral vision can be a bad thing. Presenting Bomb Wizard. It's an awesome app that helps people defuse dangerous bombs. Now, as you can imagine, defusing live bombs is a very stressful job, and that requires laser focus. If the user makes a mistake entering in the code, bad things can happen. Right now, things look nice and calm, but let's look at my original design. First, I had my super sweet animated Bomb Wizard logo and my 1990s animated welcome text. I thought that looked pretty cool. And because I'm all about making money, my cat enhancement surgery ad has been bringing in the Google ad dollars. I also thought a dancing banana could help root the user on to successfully defusing the bomb. And I also thought a live data visualization of the bomb's power could be cool too. Okay, now this is really dumb, but I think you get the point. If your user needs to focus on a specific goal, then you should look to eliminate any distractions in their peripheral vision. Let's review the attention hack. We learned that movement in the user's peripheral vision is very powerful, so we need to use it wisely. If we need the user to focus, any movement in their peripheral vision will be a distraction, so we need to keep the UI calm. However, if we need to get the user's attention, a calm UI won't attract their attention. We need to use movement. We also learned that we can signal important changes using subtle animations, and that we should turn off animated ads or anything else with movement to keep the user's focus. Okay, that's the attention hack. Next, we have the color hack. Let's make our UIs easier to see by avoiding bad color combinations. In this hack, we're not going to try to become visual designers or anything like that, but we need to avoid color combinations that can raise cognitive and emotional friction. Let's take a look at some of the more harmful color combinations. First, we always want to avoid using blue or green on a red background, or red or green on a blue background. This really raises cognitive friction as your user's brain tries to reconcile between the colors. It also raises emotional friction as the user gets upset at how hard it is to read the text. The official name for this is chromostereopsis, which I won't attempt to pronounce again. Essentially, it means hard on the eyes. These are really simple combinations to avoid. Still, there are millions of bad text and background color combinations that can hurt the user experience, and this is just an additional 4. There are a lot of ways we can get into trouble with color as developers. Now that is much better. I think my brain was actually crying after looking at that. Really, the key to picking a good text and background color combination is contrast. It's a critical factor in selecting something that will keep cognitive friction low. Let's take another look at the background colors we just saw, but this time let's use either black or white text. This hack will allow us to work with any background color and always have good contrast. But how do you know when to pick black versus white? Since we're developers, we have the universe at our fingertips. We can use code. What's cool is that using a small piece of code, we can calculate whether we should use black or white as our text color. For instance, here is a great little JavaScript function by Brian Suda that will take in a hex color value, and based on the YIQ color scheme, will output whether to use black or white. This code is simple enough that you can convert it into any language you use. I happen to be a C# developer, so I have a .NET version of this function. But that's the cool part of being developers. We can code our way around our color issues. When talking about color, it's important for us as developers to remember that some of our users may have trouble seeing colors as we intend. It's commonly called color blindness, but it's also referred to as color vision deficiency. And it affects about 5 to 8% of males and less than 1% of females. 5 to 8% is significant enough that most likely you have users with some form of color blindness. As a matter of fact, there's a good chance that some of you watching this course have a form of color deficiency. Let's take a look at 3 of the most common types. First, we have protanopia, which affects red as well as bluish-green colors. Looking at our screenshot on the left, you can see it looks radically different from the original. Next, we have deuteranopia, which affects green as well as purplish-red colors. Again, the screenshot on the left looks significantly different. And finally, we have tritanopia, which affects blue and yellow colors. As developers, we need to be careful about using color alone to represent meaning in our UIs. You often see this with using colors to represent statuses. This can really raise cognitive and emotional friction for a person with color deficiency. It's a good idea to also use an icon, an image, or text to help convey meaning versus just using a color alone. It's also good to test your UI to see how it looks. Thankfully, there are free online tools available, such as the one in the link below. This can give you insight into how others view your UI. So let's review the color hack. Clashing colors can make cognitive and emotional friction high. As developers, we need to be careful about our text and background color combination choices. There are definitely color combinations we should always avoid. We should always avoid using blue or green text on red backgrounds and red or green text on blue backgrounds. But the key to picking any text and background color combination is contrast. Contrast keeps the friction low. We learned that black or white text on a colored background is a pretty safe bet, and that we can leverage code to help us choose the right one. We also learned to be aware of users with color vision deficiency, and that we shouldn't try to rely on color alone to convey meaning in our UIs. It's a good idea to test our UIs to see how users with different forms of color deficiency will see them. Finally, for any of us that are design or color challenged, we have an easy way to test our choices. All we need to do is ask some of our users. It's an easy thing to do. Okay, that's the color hack. All right, let's circle back and review what we've learned in this module. We learned that shapes help our user's brain quickly see our UI, and that white space helps our user's brain rest while it's processing visual information. We also learned that grouping helps our user's brain understand the UI by breaking it into easy-to-process pieces. And we learned that alignment helps guide the user's central vision when they are visually scanning the UI. We also saw the power of combining white space grouping and alignment hacks, and that peripheral vision is the key to getting or losing the user's attention, that we have to use it wisely. And finally, when it comes to text and background color combinations, contrast is key. We need to consider using code to help us make our choices, as well as to take color blindness into account. We've covered a lot in this module, and I hope you can start applying these hacks, incrementally improving the user experience and lowering your users' cognitive friction today. Welcome back. My name is Keith Harvey, and this is Hacking the User's Mind. In our last module, we learned how to hack our user's vision. Now we're going to learn how to lower cognitive friction and emotional friction by directly hacking our users' minds. So let's get started. In this module, we're focusing on the user's mind and how they think, with the goal of lowering cognitive friction. These hacks can be more difficult because they often require that we make greater changes to our applications. To truly go deep with mind hacks, it pushes us closer to UX design. But this is hacking the user experience, not designing it, so we'll deliberately stay in the shallow water. Remember that user experience is the measure of friction between a user and their goal, and our goal in this course is to lower cognitive friction. But we'll also see that with some of the mind hacks, we'll be able to lower emotional friction too. So let's take a look. Our first mind hack is the leading hack. Let's make the user's brain work less by leading them to their goal. This hack is all about clearing a path between our user and their goal and making it really easy for them to understand what they need to do in our applications. So let's take a look. Here's our trusty UI from the last module. Let's put ourselves in the role of a user of this application. We need to rename some files, so what are we supposed to do? We have a tough task in front of us because, as we saw in the last module, our cognitive friction is going to be really high just trying to visually process the UI. But now we're adding a ton more friction as we try to figure out what we're supposed to do in order to rename our files. Okay, I admit it, as developers, we're pretty savvy when it comes to figuring out difficult user interfaces. But put yourself in the mindset of a person without our technical problem-solving skills. A UI like this creates a really bad user experience. The only options they have are just to give up and find something better. Now, for independent mobile or web developers, this can be a disaster, especially if you rely on your users to make a living. For enterprise developers that have a captive audience, this can be cruel and unusual punishment. But users can poke around and try to experiment, but many are often afraid that they might mess something up. And if they don't trust your UI, then no matter how good your code is on the back end, they just won't risk it. And that's not good. Another option is that they can open up help, but if a user has to open help just to achieve a basic goal, in this case rename a file, then the user experience is just plain bad. Just think about all the cognitive friction involved. The truth of the matter is that most people don't use help systems anyway because usually they suck. So most of the time they go directly to the web and use Bing or Google to do a search. I think it's really clear that all of these options are really bad. Not only does cognitive friction spike, but also emotional friction too, because not knowing what to do is extremely frustrating. So let's fix this by using the leading hack to lead our users to their goal. So here's our wireframe from the Vision Hacks module. While it has a lot less cognitive friction visually, it still puts the user in the position of asking, how do I use this thing? So let's take a look at some options we have with the leading hack. So here's our first example. The leading hack is all about getting our user from point A to point B with as little friction as possible. In this wireframe, we can clearly see the steps we need to follow in order to reach our goal of renaming our files. Remembering back to our vision hacks, we learned that our user's brain loves hierarchies, groups, and numbered lists. This is a great example of hacking that part of our user's brain. We have 3 easy-to-see groups along with a numbered list of steps. This is like tasty candy for the brain. As developers, this is as close as we can get to doing Jedi mind tricks. You will rename your files. Okay, so let's walk through the steps. First, we let the user know that they need to select the files that they want to rename. That's pretty simple. And second, the user needs to select a renaming action. And finally, we have the last step, which is the user sets up the renaming action, can see a preview, and then can finally rename their files. This type of leading can really come in handy for goals that happen infrequently. If the user is doing this every day, then they'll remember the steps pretty easily. In cases like this, we might want to offer an option to turn off the leading instructions. So here's our original wireframe again. Let's take a look at another way of implementing the leading hack, and this is called onboarding. And this is something you may have seen in web or mobile applications. When the app first loads up, the user will see a semi-transparent overlay along with some instructions. Often these are animated in, and it serves as a mini tutorial or a tour of the main goals. This technique allows us to lead the user without always being in their way. This overlay will display each time the app loads, which can be really helpful, especially when the app isn't used all the time. However, if the user has learned the UI, they can turn the onboarding overlay off for the future. Finally, they can close the onboarding overlay and get to work. Our final leading hack example is the trusty wizard. This type of leading takes a goal and breaks it down into easy steps. The primary benefit is that the user can focus solely on each step without being distracted. This is really great for lowering cognitive friction. This type of leading can work really well, especially when we as developers need to control the exact sequence of events. While it's nice to give our users freedom, sometimes that can hurt the user experience more than help it. So let's take a look at the main elements of the UI. Here we have a header area. You can also call it the header shape if you remember the shapes hack from the last module. This has a nice numbered step, which is like brain candy, some helpful instruction, as well as a nice status indicator that tells the user where they are in the process. And down at the bottom we have our navigation buttons, so the user can move next and back, as well as cancel. Overall, wizards are a really effective way of implementing the leading hack. So let's review the leading hack. This hack really fits into our definition of UX, which is the measure of friction between a user and their goal. If the user doesn't know what to do or the path to their goal is unclear, then cognitive friction is going to be high. If we can make the path clear by leading the user to their goal, then cognitive friction is going to be low, and that's our goal. When it comes to leading the user, we have multiple techniques available to us. We learned that we can use simple numbered instructional text, which we learned is also like candy for our users' brains. We also learned about using onboarding overlays when our applications start. And finally, we learned about the time-tested wizard, which not only leads the user to their goal, but also allows them to focus on each step. Okay, that's the leading hack. Next, we have the progressive hack. Let's keep the user from getting overwhelmed by only showing them what they need and when they need it. Another term for this is progressive disclosure. So let's take a look. Let's take another look at the UI we've been using to see an example of progressive disclosure, especially in the middle section. In the previous module, we learned all about the cognitive friction that is being generated by this UI with the visual issues alone. But there's another aspect that we need to consider, and that is the amount of thinking that is involved for the user to mentally process each one of the many options available. Essentially, this UI is suffering from information overload, and this is another big cause of cognitive friction. It's important to note that your user's brain isn't designed to consciously process large amounts of information. It loves focused, bite-sized chunks. Here is a wireframe that shows us the progressive hack in action. Instead of showing the user all the options at once, we show them progressively as the user needs them by moving them into a list here on the left side. When the user clicks on an option, the content area is updated with the details and input fields. This helps lower cognitive friction by progressively giving the user just the information they need to focus on. Now here's another option we could consider, but this requires a lot more research to get it right. Instead of having a list of available renaming options, we could show the most commonly used ones up front and center, and keep all the others under an Advanced Options command. When the user clicks on the Advanced Options, they get a dialog with all the available items. Now this only works if they're not frequently used. If you have users that use any of these options frequently, then their user experience is going to suffer. So let's review the progressive hack. If we give the user too much information at once, then that will make cognitive friction high as they try to figure everything out. By progressively giving the user just what they need when they need it, then we can keep cognitive friction low, and this keeps our user's brain focused. The key to making the progressive hack work is to make common, frequently used options and commands visible and available, and hide away less commonly used commands and options. In order for the progressive hack to be effective, we need to research how our applications are actually used. If your user base is small and you have access to your users, talk to as many as you can. But the best approach is to collect application usage data. Some call this application telemetry or application analytics. Essentially, this is logging every action that users take in your application so you can understand how it's really being used. This is by far the best solution I have used. Finally, the progressive hack can be used for more than just options and commands. Think about using it for your menu systems, data grids, or any other type of information that is displayed to your user. If you're putting a lot of stuff on the screen, you might be ramping up cognitive friction. Okay, that's the progressive hack. Next, we have the status hack. Let's keep our user's brain calm by keeping them informed. This hack really is focused more on emotional friction than anything else, and really relies on psychology to work. So let's take a look. Let's take a look at the wireframe we've been using as we've applied our UX hacks. A common problem developers face is when there are longer running processes that need to take place. For instance, in desktop applications, it's really easy to set the mouse cursor to a wait or busy state. As with most user experience issues, what is easy for us developers most likely is a bad user experience for our users. The problem with using standard cursors like this is that it gives the user no information, no status as to what is going on, and most likely the user has faced this horrible thing when applications have locked up. The problem with this approach is that users' cognitive and emotional friction will spike, and after a certain amount of time, they may take actions that are really bad. A common one is that they may kill the app or restart their computer, and I've seen this happen a lot. And when they do this, most often the developer hasn't accounted for it, so data gets corrupted, and the problem starts compounding. All this happens because the user doesn't know what's going on, what the status is. So let's take a look at how we can hack this. Using our previous example, let's imagine that the user started renaming a ton of files. Instead of displaying the generic wait cursor, we could display something like this, a progress dialog with a semi-transparent overlay. This gets the user's attention and lets them know that we're actively doing something for them. Since we know how many files need to be renamed, we can also pull another Jedi mind trick. Instead of just showing the user the percentage complete, we can show them how many items are left. Your user's brain loves to count down versus up, especially when it's work that has to be done. Over the years, I've found that users really respond well to this. But what do we do when we don't know how long a process is going to take? Over the years, I've found that there are very few situations where I don't know the status of what's happening in my code, even for long-running processes. It's just that most of the time, I wrote the code to make it easier for me to get the work done versus helping my user keep informed on what's going on. This forced me to refactor my code to benefit the user experience instead. While up front this was really uncomfortable for me to do, it has always paid off many times over, which really delighted users. I've even found that refactoring made the processing perform slower, all in the effort to get status information. But in all cases, the users didn't notice because they were occupied with understanding what was going on. So my challenge to you is to really consider what is truly indeterminate in your code. Still, there are times when processing is out of your control, especially if you're relying on an external system or service. In cases like this, you want to use an animated progress bar that has an indeterminate state. This is pretty common with most progress bar controls. The key here is the animation. This is one piece of the puzzle that lets the user know that something deliberate is happening. If we just use the OS level wait cursor, then the user may not trust it. The second piece of the puzzle is a status message that changes over time. For instance, here we tell the user that we're gathering metadata. And then we change the message to tell the user that we're processing. By rotating these messages on a timer during the long processing, we can keep the user's brain occupied and convinced that something is indeed happening. The key with indeterminate processing is to keep things moving. When the visual display becomes static, the user's emotional friction will start to spike, and they may think the system has locked up. The status hack really applies anywhere in your application. Here's an example of the wireframe from the leading hack, where we talked about using a wizard to lead the user to their goal. And here we're showing the user the overall status of the wizard. And we're giving them detailed information on what step they're on and where they are in the process. With our previous example, we talked about how your user's brain loves to see the amount of work remaining as it ticks down. That technique works really well for larger amounts of items, but when it comes to small numbers of steps like our example here, using the countdown technique isn't as effective. You might want to try it both ways and see which one works best for your users. Okay, let's review the status hack. If we keep our users in the dark about what's going on, then their emotional and cognitive friction is going to be high. And users in this state can do bad things, like kill our application, which can corrupt data and do other destructive things. Overall, it's just not a good situation. But we can keep friction low by keeping our users informed of what's going on. And by keeping them informed, they're more likely to keep moving towards their goal, which is exactly what we and they want. We also learned that our user's brain loves to see a number counting down, and this works best when we're processing larger numbers of items. Okay, that's the status hack. Finally, we have the recognition hack. Let's make it easy for our user's brain to recognize things versus using their memory. This hack centers around something called recognition versus recall. Essentially, this means that cognitive friction will be lower when a user can recognize something versus remember or recall it from memory. The easy thing to remember is that recognition is low friction and recall is high friction. So let's take a look at some examples of this. This is an example we've all seen a million times. Here I have a list of images in Windows Explorer, and I want to find and use a cool picture of some landing gear that I took at an air show. Just by looking at this list, I have to recall which file name is the right one. Needless to say, this generates really high cognitive and emotional friction. Well, this is the file, but there's just no way I can remember or recall it. However, if I look at the images using a thumbnail view, then I can recognize the picture of the landing gear almost instantaneously. Remembering back to our vision hacks, this allows my peripheral vision and shapes processing to help find the picture of the landing gear using low cognitive friction. I still have the data, the file name available to me, but the most important part is the actual image, the information, so that I can recognize what I'm after. A key to remember is to value information over data anytime you can. The opposite is called DRIP, data rich, information poor. For any of us that use Visual Studio, this is a great example of the recognition hack in action. IntelliSense, the pop-up that shows you the members that are available on an object, is a great example of recognition over recall. As the number of APIs have exploded over the years, it's just impossible to remember or recall all of them. Here, Visual Studio is giving us a list of members and information about them so that we can recognize what we're after. It also takes it a step further by helping us to recognize properties, methods, and events by using icons. These techniques help keep cognitive and emotional friction low by allowing developers to recognize what they're after. I can personally attest to the power of Visual Studio's IntelliSense. I don't think I could survive without it. For us as developers, we need to look where we can help our users recognize information versus try to remember and parse data. One thing we definitely need to stay away from is using abstract codes to represent information in our applications. I've seen this many times over the years, but thankfully I'm seeing less of it. I really think it's a holdover from old text-based mainframe applications where there was very little room in the UI for descriptive text. Still, I've seen it happen in modern applications. In this fictional wireframe, the developers have given each screen in the application a code, versus using a descriptive name. The problem with using codes is that users have to actively recall what the code means, versus just recognizing the name of the screen. And from what we've learned, recall is a high-friction activity, so it can be error-prone because the users have imperfect memory, to say the least. This can really apply anywhere in your application where codes can be used. Often I see developers surface a lookup table from the database into the UI without any descriptive names. We should always try to avoid that. Okay, let's review the recognition hack. Anytime we make users try to recall something, we're making cognitive friction high. And our users' memory in general can be faulty. Users can easily make mistakes when recalling information, which can lead to errors. But recognition is a low-friction activity, so anywhere we can use recognition over recall will help improve the user's experience. Also, recognition is really fast, much faster than recall. Some of the easiest ways we can implement the recognition hack is to use icons and visual previews to help users recognize information. We can also give users a list of things to choose from versus having them type it in from memory. And finally, we learned that we should avoid using abstract codes to identify things in our applications. Okay, that's the recognition hack. Wow, we have covered a lot in this module, so let's circle back and review what we've learned. Anytime that we can help lead our user to their goal, we can keep friction low, which supports our definition of user experience, which is the measure of friction between a user and their goal. We also learn that progressive disclosure, the act of giving the user just the information they need when they need it, can help keep them from getting overwhelmed, which can also lower friction. And we learn the benefits of keeping our users updated, which can really help keep emotional friction low. And it can help keep the user from doing destructive things like killing our application and possibly corrupting data. Finally, we learn that users can quickly and easily recognize information versus recalling it or remembering it. Really, the key to all of these hacks is to incrementally improve the user's experience by lowering cognitive and, in this case, emotional friction too. So I really encourage all of you to start putting these hacks into action and start lowering friction today. Welcome back. My name is Keith Harvey, and this is Testing Our UX Hacks. We've come a long way, and now we're on the final stretch, so let's get started. Just like using unit tests to ensure our code works, we need a way to test our UX hacks to ensure they're working. Remember our definition of UX, the measure of friction between a user and their goal? Well, in this module, the key word is measure. By testing our UX hacks incrementally, we can make quick adjustments to get the best results. So here's the thing. We're developers, not UX researchers. We're paid to write code, so we don't want to be bogged down with loads of UX testing. It's important to note that UX professionals put a ton of work and thought into UX testing, and some companies hire experimental psychologists to help design experiments and tests to verify their designs. But again, we're developers, so we'll keep things simple, and we'll find ways to quickly test our hacks. I promise this is pretty painless. You will enjoy testing your UX hacks. Now, I couldn't just let you get out of this module without using the Jedi hand wave, now could I? The first thing we need to do is find users that we can test. If you're an enterprise developer, then you're in a pretty good position because most likely you have easy access to the users of your application. Even if you're in a remote office, you can conduct tests using like Skype or Link or other services like GoToMeeting and WebEx. If you're a commercial or indie developer, you have a good number of options. If you have existing customers, that's a great option. Personally, I found that my customers have always been really enthusiastic about participating in simple UX tests. And if you're a mobile or web developer, you can easily use social media as a way to get test participants. That is, if you're actually a social person. There are some great online test tools that can help get your tests in front of people without any work on your part, and these are really great for getting quick feedback. And finally, don't forget about friends and family. This works really well for testing visual hacks. You just need to be aware of potential biases, like a family member that doesn't want to hurt your feelings, as well as testing one person too much. In general, I've found that testing about 5 to 10 people works really well in getting good, solid results. Let's quickly cover doing some simple in-person tests. And like I mentioned earlier, this is a great option for enterprise developers because you can easily visit users at their desks to do quick tests. If you're in a remote office, you can easily do tests online using Skype or Link screen sharing, or online meetings with services like GoToMeeting or WebEx. The easiest way to test your UX hacks is to show your users simple comparisons using screenshots or running code, and show them what the UI looked like before, and then show them the after. And always ask them to think out loud so you can hear what they're thinking. And always reassure your users by letting them know that you're testing the application and not them. That's really, really important. And if you ask your user a question, you need to ask the right question. So let's quickly learn how to ask the right questions. The first thing to know about asking a user a question is to avoid questions with yes or no answers. For instance, did you expect to see that? Or would you click that big blue button? Essentially, this shuts the user down and gives us very little information, especially if we're trying to figure out how they feel about the UI and the UX hacks that we've implemented. Instead, we can try open-ended questions like, why did you click there? Can you tell me more about that? The goal is to get the user talking so that we can find out what is going on in their brain. This really helps us understand how the user thinks and feels about what we're showing them. Next, we need to avoid questions that ask for the user's opinion. For instance, what would you like to see here? Now, it's really cool to want to please our users and get their ideas and feedback, but it can derail us and them from finding out how they feel about our UX hacks. Instead, we can try behavior-related questions like, tell me how you decided where to go next. The goal here is to understand the user's behavior because behavior is driven by the core parts of the brain that we're hacking. This helps us understand what the user really does and not what they say they do. What you'll discover over time is that our users will lie to us without even knowing it most of the time. And it's not that they're being dishonest, it's just that people's self-reporting abilities are very weak compared to how their brains really operate. So our goal is to bypass what they would say and try to focus on their behavior. Isn't psychology and UX pretty wild? It's really cool stuff, and as developers, it can make us so much more effective. Another type of question we need to avoid are leading questions. Now, these are questions that inadvertently lead our user to our desired result. For instance, how easy was this to do? Or, why didn't you click the big blue button? Couldn't you see it? Questions like this will often lead the user to giving us answers to appease us or to appease them. Like with the question, couldn't you see it? That could lead a user to say, of course I did, because they don't want to look dumb. Instead, we can try using the open and behavior-related questions that we've learned about instead. This really keeps us from cheating ourselves out of getting good data. As developers, it's smart for us to look for shortcuts to make our coding more efficient. But when it comes to dealing with our users, we need to be careful. Finally, we need to avoid priming questions, or questions that use triggers from our UI. Priming is a way of subconsciously planting a word or a suggestion into the mind of our user. Now, we're not talking about subliminal messages or anything like that. Priming is a very real thing. For instance, say we're testing the leading hack and we have a wizard in our UI. Asking the question, how would you go to the next step, would be priming the user to notice the next button in our UI. Another example might be that the user got an error message that their password had expired. Asking the question, where would you click to change your password, could prime the user to look for the Change Your Password button in our UI. Instead, we can try to rephrase our questions so that they don't prime the user with words that are in our UI. For the wizard, we could ask, tell me how you would proceed. And for the password issue, we could ask, how would you solve this problem? Again, this really keeps us from cheating ourselves out of good data. Okay, so that's some good guidelines on asking your users questions. Now let's take a look at doing some simple online testing. Like most developers, I'm always looking for good tools to help me do my work faster and better. So doing simple online tests is really appealing to me. A good example is usabilityhub.com, and there's other sites out there like this. You can set up tests really quickly, and for your users, most tests take less than a minute to complete, which is a good thing. They have 5-second tests, which shows the user a screenshot for 5 seconds and then ask them some questions. And you can also do simple comparisons where the user sees 2 screenshots and clicks on the one they like the best. There's also click tests where you can see where a user will click and see if you're expecting them to click in the right spot. And there's also navigation tests where you can actually see if a user can understand and click through your UI navigation. Now let's take a look at some basic guidance and some things to be careful of when using online testing services. When looking at using an online testing service, paid plans are much better than the free option, and this is especially true for sites like usabilityhub.com. Some of the issues you can run into with free tests is that they can yield bad data. The reason is that free options usually require you to complete other people's tests in order to earn enough points so that your test will be conducted. And you have no control over who takes your test, and it can be just another person blindly clicking through tests to earn points. So you can't really trust the results. Also, you don't get any information on the demographics of who is taking your test, and even if they would be a potential user of your application. Overall, private tests are better because you keep control of who takes your test. If you have an established user base, then you can ask them to take your tests, and then you know that you're testing the right users. Even if you do a public test, if you have a paid plan with sites like usabilityhub.com, you can get full demographics information about the people that took your test so that you can have confidence in your data. There's an old saying that goes something like this: there's no such thing as a free lunch. Well, that really applies with online testing, so just be careful. Okay, let's take a look at some of the online tests that you can take advantage of. First, we have 5-second tests, and these are good for visual hacks. We show the user a screenshot of what we're testing for 5 seconds, and then we ask them two questions. The first asks them to rate something specific. For instance, we might ask them to rate how easy it was to see something. And the second asks them if they had any negative feelings about what they saw. This really helps us to catch any emotional friction issues. 5 seconds is a very short period of time for the user to look at your UI, so try to keep your main questions very simple and focused. So let's take a look at an example of a 5-second test. Here's an example of what a user would see when taking a 5-second test using usabilityhub.com. They get some simple instructions to help lead them through the test. Hey, look, it's an example of the leading hack in action. Next, the user sees some setup information before the test starts. I like to tell them what my test is about and what I'm wanting from them so that they're prepared. Remember, 5 seconds is a very short period of time, so keep it simple and focused. Now, when the user clicks the Show Image button, the test will start. The user sees a screenshot of the UI for 5 seconds, and then they're prompted to answer our two simple questions. Now, we're going to break some of the guidelines we learned about in asking the right questions when doing in-person tests. In this case, we don't have the ability to have a real conversation with our user. And we're also trying to get quick responses after they've seen our UI for only 5 seconds. So we have to get straight to the point. In this case, I asked them a simple rating question. How easy was it to see the form? And this allows the user to quickly answer with a number from 1 to 5. And then we have the final question. Did you have any negative feelings looking at the form? And if so, what were they? This helps me identify any big issues that might be causing emotional friction. Now, these are really just suggestions, and you can ask any questions you want. Feel free to tailor your questions to fit what you're testing. I just try to keep them as simple as possible so the user doesn't have to think too much. Simple comparison tests are the easiest to do. You can show the user a side-by-side screenshot of an old and new UI, and this might be your current UI and a new version with a UX hack applied. You can also show the user a side-by-side screenshot of two variations of the same UX hack. The user can then click on the one they like the best. The key here is to keep it simple and focused, and this keeps the cognitive friction low for the user and can help you get a better answer. So let's take a look at a simple comparison test. Here's an example of a comparison test using usabilityhub.com. You can see we're actually doing what's called a click test, where a user sees some instruction and then clicks on something. We start things off by letting the user know what we're up to and what we want them to do. It's pretty simple. And then the user can start the test by clicking the button. The user will then see a single image with our two UIs side by side. Now, you don't need Photoshop skills to do this. I just use paint.net. Any free graphics app will do. And then once the user clicks, then the test is complete. It's really easy. And when you get the results, you can see where all the users clicked and you can tally up the score. Finally, we have click and navigation tests. And these work really well for testing mind hacks because you can verify if a user knows what to click or where to click next. And it's great for testing the leading hack. You can also test your navigation and menus to see if they make sense to the user, and you can verify if your commands and buttons are visible and clear enough. It's just a really good way to see where a user clicks, and if they can follow the trail you've created for them. I'm often really surprised by what users actually do. And like the other tests, it's best to keep things simple and focused so that you don't overwhelm the user. Okay, let's circle back and see what we've learned in this module. Any testing that we do helps give us confidence in our UX hacks, and it helps us to know if we're actually improving the user experience. It also gives us a chance to make quick adjustments before we get too far into making changes. And it's important to remember that we're developers, and we're the most valuable when we're writing great code and creating awesome applications. We also learn to get the best results, we need to keep our tests simple and focused. And there's some great online tools like usabilityhub.com where we can conduct tests online. We also took a look at some of the types of tests that we can run, such as the 5-second test and comparison tests, which are great for vision hacks, and click and navigation tests, which are great for mind hacks. And also we learned about live in-person tests, where we can ask our users to think out loud and get live feedback by asking the right questions. And finally, we learned that testing our UX hacks don't have to be hard or time-consuming, so I encourage you to start testing your UX hacks today. Welcome back. Once again, my name is Keith Harvey, and this is The Path Forward. If you're interested in stepping beyond hacking the user experience and actually learning to design it, then this module is for you. But even if you're not interested in UX design, I have some resources that might help you become a more sophisticated UX hacker. So let's jump in and take a look. As we start to look at the path forward, I think it's important to remember how far we've come in this course. We've learned a lot, and the cool thing is that we can now confidently explain to anyone what UX is, because it's really simple to understand. And we prepared ourselves by learning to confront the biases that can knock others off course. We also busted some of the common UX myths that have plagued developers for decades. And all of this prepared us to hack our users' vision, where we learned about central and peripheral vision and how the brain sees and processes visual information. We also learned about mind hacks and how we can help lead our users to their goals along with other cool hacks. Finally, we learned how to quickly and easily test our UX hacks so that we can have some confidence that we're actually improving the user's experience. So now the question is, what's next? As a developer with this exclusive knowledge, how can you go deeper? The answer is UX design. Now that you've taken this course, you have a strong foundation of knowledge to build on. And UX hacking is just the first step. To really make a big impact in the quality of your applications and the overall user experience, UX design is the next step. The cool thing is that there's tons of great resources available. But like a Jedi Master would say to a Padawan, be mindful of your training. Whatever you do in the future, whatever design decision you make, evaluate it against cognitive friction. Am I making the user's brain work needlessly? And emotional friction. Am I making the user feel negative emotions? And physical friction. Am I taking the user out of their physical flow of work? These are some things to always remember. Like I said, there are tons of UX design resources out there, but here are a few that I recommend if you're making the transition from UX hacking to UX design. The first is a book called 100 Things Every Designer Needs to Know About People. Another book is Designing with the Mind in Mind. And finally, we have the legendary Don't Make Me Think. These 3 books will help you create new UX hacks and will ease you into understanding more about UX design. Overall, these are 3 wonderful resources, and I can't recommend them more highly. Now, since you're a super smart developer by using Pluralsight, there is a great course on UX design that you should be aware of, and that is Creating User Experiences, Fundamental Design Principles by Billy Hollis. Billy will help you start seeing the UX design perspective, and when you watch his course, think back to your foundation of knowledge and see where the design principles can help reduce your users' friction. Okay, that's the resources I have to share with you.